Now, before I talk about this example, let me make a short note on symmetry. Let me make a short note on symmetry, and on symmetry we talk about for this shape, and for this shape we have a line of symmetry B and B prime. And we have made the definition of symmetry. We have made a definition of symmetry, and this is the definition of symmetry. But what is the its relationship with centroid? So for symmetry, that if the line of symmetry is B and B prime, the centroid of area is located on B and B prime. Okay. So if we have if we can identify, if we know the line of symmetry is B and B prime, then the centroid of area is located on B and B prime. It's located. What does it mean? It's located. 位于啊 It's okay. Now, please take a note of this, and we may use it later. Now, so we have, and we go back to example 5.5. After you have write this down, please make a note of this, and after that, go to example 5.5. And for this one, and determine the location of centroid of the arc of circle shown. So, and I asked you to memorize this the result, but how do we get this result? Now, and for this shape, because that we determine the location of centroid, that is x bar, y bar. And this x bar, y bar should be is the location of the centroid. But firstly, y bar equal to 0 because of symmetry about the x-axis. Because this arc is this. If we say this is x-axis and this is y-axis. And because this shape is symmetric about x-axis, so this is symmetric, right? This one and this one are equal. So the centroid must be located on somewhere here. Must be located on this line. The centroid is located on this line. So. And what we need to determine is centroid x bar and 0. The y bar, because y bar is equal to 0. Y bar is equal to 0. And so, to determine x bar, we consider the moment about y-axis. We assume this arc will make a moment about y-axis. Okay, this arc will make and the gravity goes in this direction. Just think about let's say consider my. So consider the moment in about y-axis here. Okay, consider M1. So for the whole shape here, the total moment is x bar times L. Because the center of the whole shape is x bar, we don't know, but as it exists. 我们有这个值，我们不知道而已啊。It exists, but we don't know. But and then the length of the line is L, and this is for the whole line. And if we look at one small part, which is let's say this part here, dl, and we have the moments about y-axis is moments arm times the length, so it is x dl. Okay, if we only take it one short section, sorry. If we take one short section, then the length is dl. Then the moment's arm is x, and then the length is dl. And of course, because this is only one short section, so we take integration about that. So that is what we have talked about on Tuesday. Now, on the previous page, we have mentioned that the length of the line and the moments about the line can be determined using this dy dx. But in a circle, we know that what's the equation of a circle if for radius r? R squared is equal to what circle? R squared is equal to x squared plus y squared, right? So it is difficult to get dy dx. So we don't use this because it is very difficult to get dy dx because the equation of circle is x squared plus y squared is equal to r squared, right? So what do we do? we work on a different way. So we have three unknowns here to get x bar. So we don't know L, we don't know x, and we don't know DL. We do them one by one. We work on them one by one, and the first part is L. L. What's the length of the whole arm? What's the length of the whole line here? You should know. L is equal to R times 2 alpha, right? Because the length of arc is equal to the radius times the angle in radian. And is that okay? I think you have learned this at high school, right? You have learned that. You have learned this at high school. So radius times angle in radian. The second part. How about x? X is a bit difficult, and let's take a look of the part 3 first, and the DL. DL here. And for DL, we take a. So how do we know the length of DL here? What we do is we use this. We draw a line here. Okay, and this one is the theta. So what is DL? Can we write DL using the theta? What's the relationship between DL and d theta here? DL is equal to R times d theta. We are still using high school things here. Now we come to the last part, that is x. And we say the location of DL is theta. So we make a right angle triangle here. So we have x is equal to R cosine theta. Does it sound logical? Can you see my right angle triangle here here? So this part is R, and so this one is R cosine theta. It's okay. The length here is R, and this is the right angle triangle, and this is theta, so this is R cosine theta. It's okay. Now we go on to we put these three things back to the equation. So we have x bar times 2 alpha R is equal to minus alpha to plus alpha r cosine theta times r d theta. I assume you understand why these three look like this, and so we put 2 alpha r to here, we put r cosine theta to here, and r d theta to here, and we get this. And of course, because our line only goes from minus alpha to plus alpha, our line only goes from minus alpha to plus alpha, so we have a definite integral. 定积分 definite integral. We have let's have a quick revision. Definite integral. We have this one. With definite integral here. So you know how to do the rest, right? So this is equal to minus alpha to alpha r squared cosine cosine theta d theta, which is equal to r squared sine theta, and then you put plus and minus alpha here, then it is equal to r squared 2r squared sine alpha. And you take this and you will get x bar. Take your time to write this down. So that is what we have. That is why we have x bar like looks like this, and this is why we have alpha must be in radian, because this part is written in radian. This part is written in radian, so this one must be in radian.